N factorial is the product of the first n positive integers. The superfactorial of n, written $n, is the product of the factorials of the first n integers. 1 factorial times 2 factorial times 3 factorial, and so on up to n factorial. For example, $3 equals 1 factorial times 2 factorial times 3 factorial, which is 12. How many factors of 7 appear in the prime factorization of $51? The superfactorial of 51? You can pause here and solve the problem before seeing the solution. Since $51 is the product of 1 factorial up through 51 factorial, the number of 7s in $51 is just the sum over k from 1 to 51 of the number of 7s in k factorial. By Legendre's formula, the exponent of 7 in k factorial is the floor of k over 7 plus the floor of k over 49. So the total is the sum over k of these two floor terms. Add up the floor of k over 7 first. It is 0 for k from 1 to 6. Then 1 for the next 7 values. 2 for the next 7. And so on. Grouping in blocks of 7 gives 7 times 1, plus 7 times 2, up to 7 times 6, plus 3 times 7 for the tail. That is 147 plus 21. Which is 168. Now add the floor of k over 49. This is 1 only when k is 49, 50, or 51, so it contributes just 3. The grand total is 168 plus 3, which is 171. So $51 has 171 factors of 7. The answer is 171.